Hello everyone, welcome back to Electrochemistry Hub. In my previous video, we learned what the reversible hydrogen electrode scale is and how to convert particular potential value from the AgAgCl reference electrode to the RHE scale. Many of you understand the equation, but one common question was during a LSV experiment, we don't get just only one potential value. We get 100 or even thousands of data points. Am I correct? So, how do we convert entire LSV curve into RHE scale? If you have the same question, don't worry. In today's videos, I will show you exactly how to do it using real LSV dataset. Okay. First, let's understand what an LSV file contains. When we perform LSV, the potentiostat records two main columns of data. The first column is the potential measured with respect to the reference electrodes such as mercury oxide, silver chloride, and so on. And the second column is the current. Sometimes it is reported as ampere or milliampere, and sometimes we convert it convert it into the current density. Okay. So today our focus is only on the potential column. So we need to convert the potential values from, let's say for example, if we use mercury oxide reference electrode, so we are going to convert the measured potential versus mercury oxide to the RHE scale. Okay, so as I told you, suppose if we use mercury oxide reference electrode and 1 molar KOH, so we know that RHE conversion equation ERHG is equal to E mercury oxide plus E naught mercury oxide plus 0.059 pH. Okay, this is the conversion equation. Okay, so what is ERHG? Potential versus reversible hydrogen electrode. So this is what we need to find out. EHGHGO is measured potential versus mercury oxide. Okay, measured potential. This is the experimental potential measured using mercury oxide reference electrode. E naught mercury oxide is the standard electrode potential of mercury oxide. Okay, so for 1 molar KOH, the pH is approximately 14. So let's substitute everything here in this equation. Before that, we know that E naught mercury oxide is 0.098 volt. Okay. So when we substitute, ERHE is equal to E mercury oxide plus 0.098 plus 0.059 into 14. 0.098 is the potential value for E naught mercury oxide. When we summarize it, we will get it ERHE is equal to E mercury oxide plus 0.924 volt. Okay. So what this is mean? This means that every potential in LSV data must be increased by 0.924 volt. Okay. So for the conversion of RHE scale. Here is the LSV data. You can find that first column is potential, second column is current. Okay. So now we are going to convert this experimental potential, which is measured using mercury oxide in 1 molar KOH electrolyte. So we are going to convert this potential value to the RHE scale. How can we convert? ERHE is equal to E naught mercury oxide. Sorry, ERHE is equal to E mercury oxide plus 0.924 volt. This is what we summarize. No, when we use mercury oxide electrode, reference electrode, and if the pH is 14, ERHE is equal to E mercury oxide plus 0.924 volt. Okay. So what we are going to do? This potential value is E mercury mercurous oxide. So we want to convert this into ERHE. So what we are going to do? We are going to add a column, that means potential column, plus 0.924. Okay, so now, so we need to keep in mind this is only for mercury mercurous oxide, and if the electrolyte pH is 14, if the pH changes, if the reference electrode changes, that conversion factor also will change. Okay, correction factor also will change. So we need to put the standard electrode potential of particular reference electrode. We need to put the exact pH when we convert into RHE scale. Okay. So this is how we need to electrode into the. I hope you all understand how to convert the potential of complete LSV data measured using different reference electrode into RHE scale. If you found this tutorial helpful, don't forget to like the video, subscribe to the channel and share it with your friends and fellow researchers. Thank you so much.